In this first example, we're looking at a limit as x approaches 1. The very first thing that I do is I check for a discontinuity at 1. And when I plug 1 into the denominator, I see that I do end up with a 0 at the denominator. So this means that there is a discontinuity and I'm going to need to factor. Let's work through the factorization of that numerator. So we're going to take the limit as x approaches 1. In the numerator, I can factor it into two binomials. So I've got an x and an x. To get that plus 2 on the end and the 3 in the middle, I'm going to need a minus 2 and a minus 1. That's going to cancel the problem, which was the x minus 1 in the denominator. Let me go ahead and cancel what I've got in the denominator. Now I end up with the limit as x approaches 1 of a different equivalent version. It's equivalent everywhere except at 1 of x minus 2. Now when I check for a discontinuity at 1, is it discontinuous at 1? It is not. So that means that I can go ahead and just plug 1 in and evaluate this by just taking f of 1. So this becomes f of 1, or 1 minus 2, which is equal to negative 1. Let's look at another example. In the second example, I have another rational function, but as I look for that discontinuity, I'm going to check my function at 3. So is it discontinuous at 3? When I plug 3 into my denominator, I get 3 minus 2, which is equal to 1, which is okay. So I do not need to do anything except for evaluate this function at 3. So this is equal to, because of the continuity, my function evaluated at 3. So I get 3 squared minus 4 divided by 3 minus 2. That's going to be 9 minus 4, 5 over 1, or 5. So make sure that you're checking for the discontinuity before you dive in and start doing some additional algebra. In this example, I checked to see if it's discontinuous at 5, and sure enough, 5 makes that denominator 0. So it is discontinuous, which means that I need to continue with factoring. I'm going to factor both the numerator and the denominator for this one. So approaches 5. Factoring that numerator into two binomials, I've got a 2x and an x, a 5 and a 1. So I'll put the 5 and the 1 here. To get that negative 9 in the middle, I need a negative by the 5 and a plus there. Difference of squares in that denominator. So x plus 5, x minus 5. And you'll notice that I'm able to cancel the problem child, right? I'm able to remove that x minus 5, which is where it was discontinuous. So I end up with a function that now is no longer discontinuous at 5. I can go ahead and evaluate this by plugging 5 in, and I end up with, let's see, 2 times 5 plus 1 divided by 5 plus 5, and that is equal to 11 tenths, or 1.1. I want to show you how to estimate this one on your calculator as well. It's really easy to do, and you can check each of your answers this way. I've got my calculator here. I'm going to put my original function into y equals as if I was going to graph. So I'm going to hit that y equals and then put my function in, very carefully using parentheses. Once I've got it typed in, I'm going to go ahead and use my table to evaluate this numerically. But I'm going to go to my table setup first. So second table set, and I want my independent variable set to ask. Then I hit enter. Now when I go to my table, I'm able to plug in numbers. Let's type some numbers in. I'm approaching 5. So let's do 4.9, 4.99, 4.999. And then I can also approach 5 from the other direction. So I can do 5.01, 5.001, and I can see that I am in fact approaching my answer of 1.1. Let's get to our last example. In this last example, I've already checked to see if this is discontinuous at the value that I'm approaching, and it is. So I do need to factor. In order to factor, I need to use a cubic factorization. So I need to use the cubic difference. So this is going to be the difference of cubes. And the difference of cubes factors like this: a minus b. That would be what is being cubed. And then I've got a squared plus ab plus b squared. Now in this case, a is equal to my 3 plus x, and b cubed is 27, so b is equal to 3. Now we're ready to apply the factorization so that we can evaluate that limit. So I still have the limit as x approaches 0. I've got an x in my denominator. Let's do the a minus b first. I'll put it in square brackets. So a is the 3 plus x. So that's going to be 3 plus x minus b. b is 3. I'll use another set of brackets here for my trinomial. So that's going to be an a squared. So I've got 3 plus x squared plus ab. So plus 3 plus x times b, which is 3, plus 3 squared. Now in that first set of parentheses, or the square brackets, my 3's cancel, which is great, and leaves me with only the x. Those x's are going to cancel, so really I've just got this second set of brackets to work with. So continuing, I've got the limit as x approaches 0. You could even simplify your life here, knowing that everything that you've got here now is continuous at 0, and you can evaluate this at 0. I'm going to do that instead of doing all of the algebra. So as I am doing this, I can replace each of my x's with a 0. Don't worry, I'm going to rewrite it here underneath in just a second. So f of 0 becomes 3 plus 0 squared, that's a 9, plus 3 plus 0 times 3, that's another 9, so plus a 9, plus 3 squared. 3 squared is also a 9, so we end up with the answer of 27. I hope this was helpful. Take a look at my other videos on limits. Thanks so much for watching.